So where the question, you will read for me or I can see
They
from
are
the...
in the Q and answer. Q and A button.
Okay, the question is that the cement production consume a lot of energy. Why renewable energy are not part of the pathway for decarbonization?
Why renewable energy is not what?
Here I mentioned that, okay. For the cement industry, we know it will consume a lot of energy, okay. So why not incorporate renewable energy, for instance, the wind power, solar power, as part of the pathway, as a new technology that can be adopted for decarbonization or to reduce other negative environmental impacts? I think this is the question.
I think I didn't say that renewable energy is not one of the key approaches for the carbon dioxide or the environmental impact reduction. Actually, renewable energy is key approach for this process. I didn't share or give details for how to apply the renewable energy. But doesn't mean that it is not important.
I understand it is difficult in your paper to include it because you focus on particular approach. But renewable energy is a key approach to reduce the carbon emission. We use carbon emission is a big pollution also. So if we use, if it is possible to use renewable energy in cement production also, to operate the whole system using renewable energy, it will, in addition to the saving energy, due to your approach, will have an additional reduction also due to the use of renewable energy. This is the issue. Maybe in the future, we can consider this.
Yes, sure. Not only in the future, but currently we already consider it. And I think it's already applied in the cement industry.
Yes, I totally agree with this. I think I also hold the same value. I think that, okay, if we can incorporate renewable energy, okay, to some extent it can help to reduce carbon dioxide emission, but it may also lead another problem. How about the economic impact, whether it is really cost effective or not? So this is also for what Professor Huang mentioned about CCUS, carbon capture, storage, and utilization. If we adapt such technology, of course, okay, 100% sure that it can help to reduce, okay, the carbon dioxide emission, to reduce the global warming potential. But in the contract, whether it will lead to the front-end operating cost will be increased a lot, whether it will be cost effective or not. So we need to make a trade-off decision, maybe between economic and environmental dimensions. Yeah. Okay. So, Professor Huang, you may go on for the second question. How can the
green circular economy? You mean this one?
Yeah. Principle be applied to
green circular economy principles to be applied to modernizing cement manufacturing to achieve substantial environmental gains, particularly in reducing carbon dioxide emissions and enhancing resource efficiency. Yeah, thank you, Professor Wang. I think I talked some relative information about how to use circular economy principles. That is the secondary materials. We can substitute the cement raw materials to other secondary materials. For example, the fly ash and other materials. Let me see. Fly ash and agricultural byproduct ash and the forestry byproduct ash, and also scrap adhesives. So all these materials can be used to substitute the raw materials for the cement production. So I think this is a good example for how to utilize circular economy principles for the cement manufacturing.
Thank you so much for your answer. I think also the one that I saw you present one slide saying that CO2 can be included, put into the cement during the production. Yes. So I think this is an excellent way of doing things. Thank you so much.
Yeah, thank you for question and for the communication. Yes, I totally agree that we can absorb the carbon dioxide. That's the new technology that already already utilized in China and also other countries. So I think this is a kind of high potential new technologies. Yeah, for utilizing
this. Is it possible for using, let's say, a blockchain system, AI, Internet of Things, just to monitor, to manage what has been said? Because very often, thing that written is not the same as what is happening in the field. So having blockchain system, AI, and all this kind of stuff, I think will help, I guess.
How is the case in Australia? Is it applied there?
Yeah, actually, we are using the AI and all this to manage the green economy. We use triple bottom line. We measure the balance of this triple bottom line by using NLP and DL to collect the story from the people in the village to see how balanced that NLP is. The triple bottom line is.
Okay.
I can share more later on in offline if you are interested. So I think it's quite interesting topic to me as well, because you know I myself, even though I'm from Australia, I born in Indonesia, and we use bamboo instead of concrete just to avoid this problem.
Okay, in Indonesia, not in Australia, yes.
Yeah, in Indonesia, not in Australia. Yeah, I'm in Australia at the moment. Yes.
I see.
Thank you. Excellent presentation. Thank you so much.
Thank you too.
Okay, thank you. Let's move to next question. From Dr. Daly.
Yeah, I also see this message. You said I didn't include clay as a part of the material substitution options. Any reason why clay is not included? Also, is clay cement an option in China? Oh, very detailed and very technical question. I think I cannot say too much, but I would say clay should be an option. And you mentioned material LC3 limestone, calcium clay cement an option for China. I should say I don't know. I don't know in detail whether the material and how the material is applied in China. But could you explain this? Could Daddy,
yes, I can.
is Daddy?
Can you hear me?
Yeah, sorry.
Okay.
Yes.
Well,
sure.
Thank you for the talk. I mean, as you correctly mentioned, 60% of the CO2 comes from the calcination of limestone. So the easiest and most straightforward way is to reduce the amount of limestone in cement. Clay, when it's calcined, does not emit any CO2. So LC3 is an approach by which substitution of clay with limestone up to 40% actually will in creating properties of the concrete that it's exceptionally similar to Portland cement as it is today. This is a direct sort of reduction of CO2 without needing to do anything else really, other than blending a new type of material. Now, clay is at least I think 1,000 times more clay in the world than there's limestone. It's very socialized. It's all around the world, and I'm sure China will have lots of clay as well in lots of different places. So I'm currently in Saudi Arabia, and we're actually looking at substitution, and we're doing some research looking at how much clay can be blended without needing to do any modifications to so the building code. And LC3 have been adopted around the world to different standards, and it's an option which is a viable option. It's all commercial currently available. I also have another question for you about CO2 curing. In my understanding, the amount of CO2 that you can store, or sort of the carbon intensity of a ton of, say, concrete, where CO2 has been used as a curing agent, is not that much different. In other words, you have to enclose it, you have to pressurize it, you have to wait for an hour or two, or even more. So that, of course, adds a lot to the cost. And I was wondering at what is sort of the cost per abatement option? In other words, yes, you can use CO2. Question is this effective? Is this cost effective? Is it really doable at the scale of the billions of tons that China produces to be able to do sort of CO2 curing? Thank you.
Thank you for your explanation. According to your first question, my colleague have left my message that yes, LC3 is a promising alternative to traditional cement that also can be applied in China. And according, answering your second question, that whether curing carbon dioxide in cement is cost-effective option here currently. Yes, it's a challenge here also. So I think we still need time to do more research and to reduce the cost so that it can be applied and promoted in the market and to utilize and in China and in other countries. So I agree with you for the second question.
Professor Huang, as for the CO2, the utilization of CO2, maybe I can share some opinion, okay? Because I have background of chemical engineering, okay? To the best of my knowledge, I can say that, okay, currently the utilization of CO2, it is not so cost effective. But we can consider how to make it more effective, especially if we want to use CO2, the most important about the energy efficiency, okay, whether we have enough energy, whether it will cause more environmental problem, okay. We know CO2 can be through capture, through transportation, utilization, then CO2 can be converted into value-added product or into green energy, finally into methanol, into DME, into DMC. But the problem currently is that, okay, how we can make it more effective. Actually, just like Professor had mentioned before, how we can incorporate the concept of circular economy into zero waste strategy. For instance, in cement production, it will also cause some other waste. For instance, the fly ash, just like Professor Huang had mentioned in your presentation. Okay, actually, fly ash, it is a kind of material which can be used to produce a special kind of product for carbon capture. So in this way, it means that, okay, for all the cement powder and also all the fly ash can also be used maybe in carbon capture. In such a way, okay, the energy problem any problem existing in carbon dioxide utilization can be successfully solved. Okay, thank you.
Thank you.
Of course, avoidance is the first the first strategy. It's not produce CO2, then you have to deal with it. Yeah, and to be able to cure it with CO2, you have to capture it, and pressurize it, and put it in. But
yeah. Okay, so any other questions?
I can see a question from Perry, Lynn Perry, ask about the fly ash, whether fly ash can be an option for the substitution. I think I mentioned it in my slide that fly ash indeed is should be good option for the substitution. But in China we haven't will applied it. So which means it's great potential here.
Yeah, this is also what I mentioned. Okay, actually, fly ash, it is also kind of resource to produce a kind of material for carbon capture. Yeah.
Yes.
Similarly, okay, for some other functions, the waste heat actually can also be integrated, okay, in the whole circular economy configuration to achieve better energy efficiency.
Yeah, I think that's the questions live in the chat screen. Do you have other questions, Professor Ren, from your side?
No, I do not have any question. I think over it is very clear. Yeah.
So is there anyone want to talk or want to
so if possible, so we still have some time. So Professor Wang, if possible, so we have seen that you have already analyzed the through scenario analysis. Okay, you have analyzed the environmental gains. Okay, how about the environmental benefits that can be that can bring by some new and advanced technologies such what have you mentioned before, how we can incorporate renewable energy about CCUS and also some new production pathways. So have you considered how about some other aspect of sustainability? As well know, sustainability usually emphasize on three aspects: economic, environmental, and social aspect. You have analyzed the environmental aspect in detail. So how do you think about the economic and also social performance of the technologies? Okay, where the front end environmental impact, where it is cost effective? How about the capital cost? And also about the social impact, how about the social stability, and also how about the safety and the risk? Okay, so if you have some idea about this, you could share to us. Thank you.
Thank you for the question. You are asking about the social benefits for the technology transformation or say upgrading. We didn't look into the details and we didn't quantify those social benefits, but I think obviously here there are obvious the social benefits. If the environmental pollution is mitigated and the air quality, the air quality and the local environmental quality will be enhanced for those cement plant regions. So the local people can benefit from it. And I think that's the key side of the social benefits. And because of the technology upgrading, the cement industry can offer more job opportunities for the local people, and that is also another good benefits, I think.
Okay, thank you. That's good. I do not have any further question.
May I have one question?
Sure.
Dr. Huang, actually, I would like to ask, there's a lot of plastic around the world. Is it possible to use that material to mix with cement to build the building? Is that will be strong enough? Is that an alternative? In some area, they use as a paving already. So if we can actually use as a material for concrete, that will be good. Then our ocean will be clean again, hopefully.
You mean the plastic materials?
Yes. See, there's a lot of organic and unorganic. So we focus on unorganic material and somehow mix with cement to make a building or something like that. But the problem is I'm not in that area, so I'm not sure it's strong enough for to be used for building.
Because I personally didn't do experiment. I'm not an experiment scholar, so I think my answer I don't know, but I assume that it will be a potential material that can be applied in the future. I think I can only say
that will be good if we can actually make that happen.
Yes, here are opportunities for different coming new materials. So yeah, let's explore.
Okay, thank you.
Yeah.
Okay, so any other question?
But I think the plastic, the challenge here, I think, is that the material should come from the nature, and it can be also absorbed and digest. Yeah, from for the nature, so it doesn't cause any other new environmental pollution challenges. That's what I think now.
Yeah. At the moment, this material actually, polluting the sea, and in the end, we are the one that consuming all the fish and the plastic as well.
Yes.